Yesterday, Eric Hartford from Abacus AI interleaved Mistral 7 billion into a larger model and created Big Stall 12 billion model, which I showed you how to get locally installed and play around with it. That was one of the best merged model I have seen in a long time. And just few hours later, Eric has done it again, and this time he has interleaved or merged Bigyi 15 billion. He has fine-tuned it from this Bigyi 9 billion model, and this model is again has been merged through the pass-through merge technique. In this video, I am going to show you how you can get it locally installed and play around with it. Before I do that, let me give you a very quick overview of this model. As I said that this model uses pass-through merge technique of merge kit. So what Eric has done it, he has just taken this model here, which is Bigyi 9 billion model, and has created this Bigyi 15 billion model by interleaving the layers of Bigyi 9 billion. He has used a merge kit for it, and this is a YAML file he has used in order to use the merge method pass through. The pass-through merge method described here involves a sequential and overlapping strategy for merging different slices of the same base model, in this case Bigyi 9 billion, where each slice processes a specific range of layers. This method allows the output from one slice to be directly used as input to the next, ensuring a continuous flow of information and context through the model. The slices are defined to overlap in their layer ranges, suggesting that each part of the model not only processes a distinct segment of the overall architecture, but also integrates insight from the previous segment, enhancing the depth and richness of the processing. This approach aims to leverage the strength of different layers within the model by creating a more nuanced, efficient, and effective processing pipeline, where data is refined and enriched as it passes through successive segments of the model. Now, if you look at this file, it is not that hard to follow. For example, if you start from this D type float 16, this is indicating that the data processed and passed through the model uses 16-bit floating point number. This choice can help reduce memory usage and speed up computation, which is particularly beneficial for deploying large language models in an environment with limited resources. And then we are specifying merge method, which is a pass-through, and which I have described in detail what exactly merge through is. And then afterwards there is all this slicing information or configuration. So the model has been divided into slices based on the layer range. Each slice takes a portion of the model layer and is designated to process the data sequentially. The first slice uses layer 0 to 12 here, and the second slice layer 6 to 18, and then this pattern continues with each subsequent slice starting from the middle of the previous slice layer range and extending beyond it. So this setup suggests an overlapping and sequential processing strategy. Each slice begins partway through the previous slice range and extends into new layer. So this is to ensure, in my humble opinion, that each portion of the model processes input with some context from the preceding stage, potentially enriching the feature extraction or decision making process. In my opinion, this arrangement allows different parts of the model to focus on processing different types of information or to refine the output of the previous layer. And this obviously enhances efficiency and performance and also extends the size of the model, especially the context. There are a lot of other nitty-gritties in that. You can visit MergeKit's website to learn more about it, but this is simply amazing. Okay, now enough theory. Let me take you to my local system where we will be installing this model. This is my Ubuntu system where I'm using Ubuntu 22.04. I have 1 GPU of 16 GB VRAM and 32 GB of memory, and you would need plenty of hard disk space. I think it is around more than 30 GB model. It is not a quantized one which I'm going to install, it is a full-blown one. Okay, so let me clear my screen and fire up my Python interpreter. Make sure that you have transformers and library installed. Plus I believe it would also require you to install bits and bytes, also accelerate library. So, and of course PyTorch is always there. So once you have it, fire up your Python interpreter. Now first thing you need to do is to import some of the libraries like torch and transformer modules. If you don't know what they are, I have described them in great details in my other videos, so please search the channel, you will find them. Now let's store the name of the model Bigyi 15 billion in our variable. I have one GPU, so I am going to use CUDA here, and I would highly suggest that you do it on GPU. I don't think so it is going to work on CPU. Okay, let's download our model. This should be fairly quick for me because I already ran this, so it has downloaded the model. So it will download around 4 shards for you of total 30 GB size. So let's wait for it to finish. It is just checkpointing those shards which are already present on my local system, so it should be quick. When I was downloading it, it was taking a bit of a time due to my internet bandwidth. So if you are doing it first time, bear with it, it eventually finishes. Almost there, 50% shards are done. It is just loading it on my GPU memory and all, checkpointing it. That is done. Let's specify the auto tokenizer. That is also done. Now let me give it a prompt in one of the variable. So in this prompt I'm asking it, how do you feed your pet fox? Please answer this question in 6 simple steps, and then I am just putting /n step 1 there because it's a completion one. Now let's input that prompt into my tokenizer. That is done. Let's ask model to generate our output, and I'm just using 500 length for the output just to make sure I get something handy out of it, and you can ignore this warning. Shouldn't take too long. It is generating the response of my prompt at the moment. Once that's done, I am going to print it out, and I'm letting it run just to show you the speed of inference on my local system for the first prompt. Let's wait for it to come back. So I think because even 16 GB of VRAM is less for this model, hopefully it won't go out of memory. So if you have access to the larger VRAM GPU, I think this inference speed should improve. So let's wait for it to come back. It has generated the output. Let me make some more room, and now I'm going to print the output. There you go. So it has given me 6 steps here. As you can see, it is hallucinating a bit too, but that is fine, and it is just telling me what exactly fox prefer there. Awesome. Let me clear my screen, and then we will ask it few other things. Let me put another prompt here. Now in the next prompt I'm asking it, what's a fascinating story about a historical figure that sounds like fiction but is actually true? Let me send it to model and generate the output. Let's wait for it to come back. So it has come back. Let me print it. So the question was, what's a fascinating story about a historical figure? Okay, so it is hallucinating. It says close duplicate, didn't answer me. Okay, so that is a fail for the model. Let me clear my screen. Let me ask it another prompt here. So I'm asking it, describe a technology that doesn't exist today but could change the world in 50 years, including how it works and its impact. Okay, let me send it to the tokenizer and then print it out. Let's see what it does. And I'm just keeping it raw. I'm not editing any output. So just to give you a very fair and neutral review of this new model. Let's wait for it to come back. Okay, so let's print the response to this one. Okay, it says that the winning entry will receive a $10,000 scholarship to help fund their education. Okay, I don't know what this is harping about. Doesn't look that cool to me. I think that's a fail. It is hallucinating here. Okay, let's clear the screen. Let's give it one final one. If humanity discovered that the entire universe was a simulation, how might this knowledge change our approach to ethics, life, and society? Let's see if model is able to do something about it. Let me press enter, and then let me paste that input to the tokenizer, and then let the model generate the output. So far, in my opinion, it has just given us correct answer of the first prompt, that was correct, but for the second one it was okay, but for rest of them it just hallucinated. Let's see what it does with this one. Model has come back. Let me print the response. That is nice. You see that it says that the concept of a simulated new universe has been explored in various forms of fiction, including the movie The Matrix. And okay, so it is discussing the movie, and then one potential impact of discovering that a universe is simulation is that it could lead to a shift in our understanding of ethics and morality. Awesome. Beautiful. I think this one is just flying colors. Really like this response. And just to finish it, let me ask one of my favorite questions. So I'm asking it, which one came first, egg or chicken? Let's see what model says here. So the model has come back. Let me print the response. There you go. So the answer is both. It's a chicken and egg problem. The same is true for the relationship between the brain and body. The brain and body are connected and interdependent. The brain controls the body. Wow, what an example. Awesome. The brain controls the body, but the body affects the brain. The brain and body. Okay, so it has just taken it to another level. It has just given me an analogy and going. So I think this is awesome answer. This is also a huge pass, I would say. Awesome stuff. And you can see that I could just keep playing with it whole day. So that's it, guys. I hope that you enjoyed it. Please install it if you want to, and then let me know your experience with it. I think another good model by Eric. If I compare both this one and the Big Stroll, I think Big Stroll was better than this. This is not bad, but Big Stroll was just simply the best merge model in pass-through I have seen so far. Bigyi is also good, but lags behind in some of the analytical questions. But all in all, a good model. Let me know your thoughts in the comments, and if you like the content, then please consider subscribing to the channel. And if you're already subscribed, please do me a personal favor and share it among your network, as that helps a lot. And thank you to Eric Hartford for this effort. Thank you.